All right, we want to begin to use our factoring skills in the practical way that they were meant to be used. And one of those is something called the zero product property. Now, before we dive into that on the next slide, first just want to tell you we'll see all kinds of versions of this, but primarily we're going to see quadratic equations that we're going to try to solve. A quadratic equation is something that has an x squared as the highest exponent. So x to the second power. If that's the highest exponent in an equation, it's called a quadratic equation. Now here's the zero product property. This is what it means. If suppose I have two numbers, and I don't know what either one of them is. Well, wouldn't it be true that if x turns out to be 0, then everything's going to be 0? So if x is 0 and y turns out to be 5, it's 0. And the same is true the other way around. If, say, this is 2 and y turns out to be 0, it makes the whole thing 0, right? Okay, so now here's the application of that. Now we haven't factored this one, it's already been done for us. But if I have something factored and now it's an equation, it now equals 0, I can now solve it. And so what I'm going to do is set either one of those factored terms equal to 0 and solve. So here we are doing it. Now if either one of those is 0, the whole thing is 0, so I need to solve them both. So just solving these old school, I'm just solving it for n. I'd get 2/5 and 1/6. You see what we're doing here, just solving both of these, just old school algebra. Okay, now they've checked them to confirm it. It's going to be true. There's some other kind of equations where sometimes it's not always true, but these are going to be true. So, you know how we do this. Pause it if you want to try. I'm just going to set each of those equal to 0, because if either one of them is 0, the whole thing is 0. And I'm just going to jump right ahead. I'm adding the 2 to the other side and dividing by 3. Here I'm subtracting the 1 and then dividing by 2. I'm doing all that in one step. Hope you're with me there. Okay, now here's where we're going. If we want to use our factoring skills to do this, where we have to begin is the right side of this equation, or one of the sides, has to equal 0. It only works if it equals 0. So this zero product rule is only going to work if 0 on one side, everything else is on the other. So here, all we're going to do is swing everything to the other side. So I'm subtracting 3y, I'm subtracting 45, so that I left this room empty and equal to 0. Okay, now we're factoring here. Now, I'm not going to go through all the steps they AC, or I would AC method this. They could have guessed and checked it, but they factored this. Now, this isn't a video about factoring. I may show you some of them, but this has been done for us. So now it's time to set each of them equal to 0. And you get y is -5/2 and y is 9. Okay, they've got the check there for you too. Okay, now try it. Send everything over to one side, set it equal to 0. Okay, I've got everything over there. Now let's factor it. Now I just said I wasn't going to factor a bunch, but yes, I guess I am. So the AC method is the way I'm going with this. 3, -8, -24. So I need two numbers. No, that's not it. Yeah, I got tricked because there were multiple combinations. It's going to be -12 and 2. If you don't remember how to do this, go back to the old videos. Okay, when you're doing one of these, you're not done yet. If you got the match, you're right, but you're not finished. All right, now all of that was just to get it factored. We're going to set both of these equal to 0 and then solve them. And we got it. Okay, now it's always the same idea. We're just going to use our different various factoring skills to solve these. I need 0 on one side, so I'm going to move the 49 over. And now, GCF, no. Do you have square roots on the front and the back? I do. So there's no middle term, so it gets opposite signs. We solve this. I don't know what happened there, but you're going to get plus or minus 7 over 13. You're going to get both versions of it. Okay, this is going to follow the same pattern. Stop and try it if you want to. Okay, I'm getting it so that it's 0 on one side. Now I've got square roots on the front and the back. So I'm not showing the steps. I hope you're comfortable with that. I'm just sending 7 over, dividing by 5. All right, now this is where things get rather difficult, rather unpleasant actually. When we have something like this, I can't get 0 on one side until I've multiplied everything out. So basically, we're going to FOIL it out, then move the 3x over, and then factor it again. So not very much fun, but you can do it. You got the skills for this. So this on the left, I'm FOILing it out, and I would get this. Now, I need this room on the right to be empty, so I'm going to send the 3x over to the other side. Now, once you've done that, you create 3x squared minus 4x plus 8. Now remember, these are like terms. The x squared, that's a different thing, so they don't combine. These combine, we factor, and now since we have 0 over there, we can use our 0 product property, solve it, and we get these two answers, 4 and 2/3. Okay, I'd really recommend you stop it and try the video for this one, and I'll show it. Alright, so far all I've done is FOIL that out and put it combined like terms. Now we're going to subtract 12m from both sides. Well, I thought I could just do this in my head, and I should be able to, but I don't do the trial and error method very much. Why is that not working? Yeah, there we go. Okay, that's how to do it. So you can AC method that. I was trying to trial and error, and as you can see, that's not the way to go because it'll mess me up. So I get negative 2m, negative 3m, and I got it. Okay, now solve each of these. We get set of me. Well, I better show that. What I'm doing, the whole point of the video here, so I should show it. This is what I'm doing, setting each of those factors equal to 0. So I've got m is 3 over 2, and m is 1. All right, this is one of theirs. So it looks to be the same. Oh, I think I see where this is going. So first we're going to move everything over. Now, we want to factor. So for factoring, we always take a GCF, and this has a GCF. So notice a 3 pulls out of here. Now we've got something that we can factor relatively easily, and we get down to here. Now here's where students will have trouble with this. The 0 product property applies to all 3 of these things are being multiplied together. So if any of them is 0, the whole thing is 0. But 3 is never going to turn into 0. So if I'm solving this, it actually has nothing to do with it at all. So I'll just have to worry about, so 3 can never equal 0, so that's fine. It's not going to be part of the answer. But I set the other 2 equal to 0, and I've get my 2 solutions. Okay, try this one. We got to move that over from the right to the left. Okay, can I do any better than the number 3? I don't think so. So I'm pulling out a 3. Yeah. Okay, so sometimes you leave, you don't get the greatest common factor. I think I got it. Double check, it looks like I'm right. All right, so we've got 6 and negative 10. So I'm going to put that over here. Okay, is this one going to be an easy one to see or not? Yeah, it is. Okay, so 15 and negative 4 will make negative 60. So I'm going to do 6a squared. Okay, now I'm going to come back to that 3, but I'm just going to finish the AC method here. So I'm pulling a 3a out of there. I'm pulling a negative 2. Remember that, because it starts with a minus. Changes the sign on the back. So, again, I'm not saying everything through these processes here, because we've done the factoring. So go back if I'm going too fast for you. Okay, this is where we get it down to. Now the 3 can never be part of the problem. It can never equal 0. So all I've got to do is solve those two. So a is 5 halves and a is 2 thirds. All right, now I know what's happening with this one. Let's bring this over to the other side. We've got the negative 60m squared. Now this time, always check for a GCF. Well, we have it. It's an m though, however. So I have a perfect, do I? Yeah, I do. I've got square roots on the front and the back here. So now I have a perfect square trinomial. So I can factor that down really easily. But look what happens. This m out front, 3 things are being multiplied together. There are 3 factors, m, 3m minus 10, 3m minus 10. Now, any of those could equal 0. Well, because m is now a variable, maybe it's the problem. Maybe m is 0. So I have to check this one because I pulled out a GCF that had a variable. Now these two are the same answer, so that's fine. We'll just have the 2 solutions, 0 and 10 thirds. So this time a GCF involved a variable. Well, that could be 0. So we need to set that equal to 0 as well. Last time it was a 3, which could not. Okay, try one. I've got to move everything over to the other side. All right, so seeing what I should pull out of there. That looks to be all I can do. Okay, now just like in theirs, I've got a perfect square trinomial. Square roots on the front and the back, so I'm going to do those twice. I got a middle term, it's got a minus in there, so minus minus. That's absolutely terrible. Sorry about that. Okay, now I have 3 things being multiplied together. Any of them could cause the problem, so I've got to set them all equal to 0. Now these two are the same, so it's going to be the same number, so I'm not going to write that twice. But when I solve this, I get x is 0 and 3 halves. Okay, I think that's pretty good coverage of all the possibilities that you can have. So we're looking at solving equations now, so there are answers. But what we're going to do is use the zero product property along with our amazing factoring skills to solve these.